Now, please tell me, can you see the screen?
Yes, miss.
Yes, miss. Yeah, go ahead.
Okay. So, today we will do some math which are actually applications of maxima and minima. How to apply the theory of maximum and minimum in our real life problems. So, at first, this is the question. The profit of a certain cell phone manufacturer can be represented by this. Px equal to minus 2000 x cube plus 12,000 x square plus this into x. So this P is the profit. Just a minute. So this P is the profit. You see, this P is the profit in dollars, and X is the production level in thousands of units. In thousands of units means a product of number 1000 is taken as 1 unit. Okay, so this X represent 1000 unit of this certain product. And P is the profit. And your question is how many units? That means the value of X. For what value of X? How many units means for what values of X should be produced to maximize the profit. So this is a question of maxima minima. Your question is what should be the value of this X? That means what should be your production level to get a maximum profit. Okay, to get a maximum profit. So this is our question. Now, for a function, if it is a continuous function, mm, um, okay, at some points, if it is continuous, what are the critical points? Okay, let us go through it like this. A function can have a maximum or minimum. A function can have a relative maximum or minimum at a critical point. Other than critical point, the function cannot have any maximum or minimum. Relative, of course. Cannot have any relative maximum or minimum at any other point which is not a critical point. So the maximum or relative maximum or minimum can occur only at critical points. So you have to find, at first you have to find the critical points of this function. And at critical points, there may be maximum, there may be minimum. And we have to test it whether at the critical points you are getting a maximum value or a minimum value. Now you see, this is a function of x. This profit is a function of x, you see. This is a polynomial function and the variable is x. The function is denoted by p and it is continuous. This is a polynomial function, so it is continuous everywhere for all real values of x. So at first we find the derivative. Let us find the derivative. So this is your px and p prime. P prime means d dx of px. So what is the d dx of this? You have to differentiate term by term. So d dx, this is constant. So d dx of x cube means 3x squared. So 3 into minus 2000 is minus 6000 into x squared. And here x squared, for x squared it will be 2x. So 2 into 12,000 means 24,000 into x. And here d dx of x is 1. So just this number. This is the constant coefficient. Okay. Now from this expression, you can take minus 6,000 common. So you have what? X square. This will be minus x square minus 4x minus 21. Okay. And let us find the factors of this expression. It will be, apply the middle term factoring method. Apply the middle term factoring method and your factors will be this, x minus 7 into x plus 3. So you see this derivative is also a polynomial function. So it is everywhere continuous. This function this function, the derivative of x, it is defined everywhere and it is continuous everywhere. So this p prime x exists everywhere. So there is no point where this p prime x is undefined. Undefined means the value of the function should be infinity. If the value of the function is infinity, then we say that it is undefined. So there is no point where the derivative is undefined. So for the critical points, we have only one condition, that p prime x should be equal to 0. So if you take this equal to 0, what will be the values of x? The values of x will be what? -3 and 7. Could you follow me?
Yes, miss.
Okay, so if p prime x equal to 0, you know, for critical points, either p prime x equal to 0 or p prime x does not exist. Here, p prime x exists everywhere for all values of x, for all real values of x. So for an extrema means for a maxima, relative maxima or minima, p prime x equal to 0, this will be the only condition which gives us x equal to -3 or x equal to 7. So now we will test whether at these 2 points there is a maximum or minimum. So this is a very easy function. It was a polynomial function. So it is very easy for us to get the second order derivative. Just differentiate it again. So if you differentiate these terms again, it will be minus 12,000 into x plus 24,000. Yes. You take the second order derivative. P double prime x means it is the second order derivative. It will be minus 12,000 into x plus 24,000. You can take minus 12,000 common, so it will be x minus 2. Now, what are the points, critical points? These are these are 7 and minus 3. At first, we put x equal to
7.
Yes, x equal to 7, so it will be 7 minus 2 is 5 and it is a negative number. So at x equal to 7,
You get
you know,
maximum.
it will be a maximum.
Yes.
Yes, because you know, in the second derivative test, if the second order derivative has the negative value, then at that particular point, the function will have a maximum, relative maximum. So you see, at x equal to 7, this profit, the original function was p of x, which is the profit. The profit will be maximum when x equal to 7. So what will be our production unit? It will be 7 into 1000, because x was equal to what? X stands for 1000 units of production. So there should be 7000 units of production should be there to get a maximum profit, to maximize the profit or to get a maximum profit. You can check for this one also. If you put x equal to -3, what happens? If you put x equal to -3, it will be -5, and -5 into -12,000, it will be a positive number. So when x equal to -3, that will then there will be a minimum profit, isn't it? There will be a minimum profit, because your question was to get the value of x. To get the value of x means you have to find the production level. Production, how many units? So after finding the value of x, you must multiply by 1000, because x was the production level in 1000 unit, and your question was what should be the units to be produced to maximize the profit. So x equal to 7 means 7000 units should be produced to get a maximum profit.
Miss, x equals to -3 is also a critical point, right?
Definitely. X equal to -3 is a critical point. Definitely. I have written it here.
Miss, এখানে just because so x equals to 7 is the only critical point.
Yes. No. Oh, yes. Oh, I think, oh, sorry. X equal to -3 is a critical point, no doubt in it. But in this case, you cannot take x equal to -3. That is true. So finally, you don't need to test for this -3. Why x cannot be equal to -3? Because x was the production level.
Production
X
can't
was
be
the
negative.
production level. It cannot be a negative number. It cannot be a negative number. So x cannot be equal to -3. That's why You don't need, this is a critical point, no doubt in it. X equal to minus 3 is a critical point for this function, for the function px, x equal to minus 3 and x equal to 7. These two are the critical points, but here for this particular math, for this particular problem, x cannot be equal to minus 3 because x gives you the production level, which cannot be negative. So here, since x cannot be minus 3, so we don't need to test for this critical point x equal to minus 3. We need to test only for x equal to 7. So I was wrong. I was discussing the thing when to test for when x equal to minus 3. Actually, x cannot be equal to minus 3.
Miss,
Yes.
Miss, if second derivative test shows undefined or infinity, then what will be the
Okay.
result? I mean,
Okay, suppose the second derivative, for this particular math, there cannot be undefined because it was a polynomial function. Dp double prime, the second order derivative is also a polynomial function. Suppose the second order derivative becomes undefined at a critical point, okay, becomes undefined at a critical point, then you cannot use the second, you are not getting any result actually. You are not getting any result from the second derivative test. So that for that particular critical point, you have to go back to first derivative test, because using the first derivative test, you will always get a conclusion whether there is a maximum or a minimum, because it depends on the changes of the sign of the first order derivative. Okay, if there is no change of sign, there will be no maximum minimum, and if there is a change of sign, that means if it changes from positive to negative, you must start from a number which is less than the critical point. Suppose your critical point is 7, okay, you can do this math, you can solve this math using not using finding the second order derivative. You can directly use the first order derivative. Suppose the point is 7, okay, so you to use the first order derivative, the first point should be 7 minus h. That means a point which is less than 7, and then at first use a number which is less than the critical point. So the first number should be 7 minus h, where h is a positive number. 7 minus h and then 7 plus h. And if the sign of the derivative changes from positive to negative, there will be a maximum. And if the sign of the derivative changes from negative to positive, there will be a minimum, relative minimum. Okay? Is it clear to you now?
yes,
Is
Miss.
it? Okay. Let us now go to the second math. Next math. Find the dimensions of the rectangle with maximum area that can be inscribed in a circle of radius 10 centimeter. So you have a rectangle and a circle, and you have to enclose this rectangle by this circle whose radius is 10 centimeter. And you have to find the dimensions of the rectangle for which the area of this rectangle will be maximum. Okay, so let us inscribe or put this rectangle inside the circle. When you put a rectangle inside the circle, it is obvious that the center of the circle will be at the point of intersection of the diagonals of the rectangle. It will always happen. The point of intersection of the diagonal, two diagonals of the rectangle will be at the center of the circle. So this will be the position of the rectangle inside this circle. Okay, now we know two things. One thing, actually, we know one thing, that the radius of the circle is 10 centimeters. So this length from this center up to this, it is 10 centimeter. Okay, let us now take, suppose the length of the rectangle be x and another side be y. Another side be y. So what will be the area of this circle? Sorry, rectangle. Area of this rectangle will be what? X into y. Let us denote it by a. So area of the rectangle will be a into xy. And now let us look into this figure. This triangle. Okay, I have written here BCD, but I did not mention the vertices. Okay. So this angle is 90° and BCD will be this triangle. You please put you can put it here B, C, D, or A, B, C, D. It would be better. A, this is A, then B, then C, then D. So BCD is a right triangle, and you see this is the hypotenuse. This is the diameter and also the diagonal of the rectangle. This line is the diagonal of the rectangle, and also it is the diameter of the radius. So here, from the property of right triangle, you know, x square plus y square will be equal to the hypotenuse square. Hypotenuse is this. The radius is 10 centimeter, so the length of this full diameter will be 20. So it should be like this: x square plus y square equal to 20 square. Yes, x square plus y square equal to 20 square. So here let us find the value of y square. Y square will be 400 minus x square. Okay, 400 minus x square. Now let us go back to the expression for the area. It is a equal to x into y. There are two variables, one is x and the other is y. So let us try to express this area in terms of a single variable. So let us put down the value of y here. Y square is 400 minus x square, so y should be root over 400 minus x square. Here we are not considering the plus minus sign because these x and y both are giving you the lengths of the sides of the rectangle. So you cannot take the negative sign, only the positive sign. So here in this case, when you put the value of y is in terms of x, so this area becomes wholly as a function of x. So now you can write it like this: a of x. So this area is a function of x, and the expression is this x into y. Y means root over 400 minus x square. Okay, so this is our function now. This is our function. This is the area function, which is a function of x, and the expression is this. It is not a polynomial function because here there is a square root. Okay, but you know that for any function, for maximum or minimum, of that function, either a prime x equal to 0 or a prime x should be undefined. I have written it here. For maximum or minimum of the area of the rectangle, either a prime x equal to 0 or a prime x does not exist. So at first we have to find the derivative. So you see, it is a product of two functions. The first function is x and the second function is root over 400 minus x square. So one part, suppose this part is taken as fixed. This is u into v into d dx of u. This is your u. So d dx of x is 1. So it is just 1. Root over 400 minus x square plus. Then you keep this x fixed and find the d dx of this part. So you have to consider this 400 minus x square as your simple x. So root over means power half. So it is actually x to the power half. So what will be the derivative? This x remains here, this x into d dx of x to the power half means half into x to the power 1 minus, sorry, half minus 1, that means minus half. So the power will be half and your x is 400 minus x square. So this half into this whole thing is your x, half into x to the power minus half, then d dx of this whole thing, because you have considered this whole thing as x, but it is not x. It is 400 minus x square. So you have to find the d dx of these terms again, multiply. So what is the d dx of this? 400 is constant, and from this minus x squared you will get minus 2x. So you have to multiply it by minus 2x. This comes from the chain rule. So here these two and this 2 cancel out. This is the first term, and here this x into x is x square. This minus sign comes here. So in the upper part there will be x square and the power is minus half. So let us take it to the lower side. It will be 400 minus x square whole to the power half. That means root over 400 minus x square. Now let us do this algebra. Your LCM will be root over 400 minus x square. and you have to multiply this and this. So 400 minus x square minus x square. So in the upper part, for this first order derivative, a prime x, you are getting what? 400 minus 2x square. This is the expression for the first order derivative. Now, you know, for maximum or minimum of the area, your area was A, and this is the first derivative of this A. So either a prime x equal to 0 or a prime x does not exist. So you see here a prime x does not exist when x square equal to 400. When x square equal to 400, okay? So x should be equal to 20. Now let us check whether x can be equal to 20. Is it possible here for x to be 20? Because your hypotenuse was 20. If for this right triangle, hypotenuse is the largest side. Hypotenuse is the largest side and it is the diameter of the circle. So this diameter must be greater than this side and this side. So this x cannot be equal to 20. Is it clear?
Yes, miss.
Okay, so since x cannot be equal to 20, so we at this point x equal to, it is a critical point, but for this particular math, x cannot be equal to 20. So now you have to check for what values of x, a prime x equals to 0. So when a prime x equal to 0, this 400 should be equal to 2x square. That means x square should be equal to 200. That means x should be equal to 10 into root 2. 10 into root 2. We are avoiding the negative sign because x cannot be negative. So this is the point at which we have to test whether there is a maximum or minimum for the area. Now you can use first order derivative test or you can use second order derivative test. It is up to you. Here this function is not a polynomial function, so you could have tried with the first order derivative, but here I have found the second order derivative. So it is of the form what? U by V. Quotient rule. So you have to apply the quotient rule. What is the quotient rule? In the denominator, it should be root over 400 minus x square whole square. And in the upper side, this denominator into d dx of the upper part. Lower part into d dx of the upper part minus upper part into d dx of the lower part. This is your formula. So the lower part into d dx of the upper part. D dx of the upper part will be minus 4x. Then minus the upper part 400 minus 2x square into d dx of this. You know, you have to find the d dx of this. We have already found it here. We have already found it here. Where? Yes, it was found it here. So what will be the derivative of this lower part? It will be this half. This x was coming from this, but here we do not have any x. So it will be half. Half into 400 minus x square whole to the power minus 5 into minus 2x. Yes. 400 minus 2x square, it was the upper part. Upper part into d dx of lower part. D dx of lower part is this. I think I have done some mistake here. There should be a half here. Isn't it? 400 minus 2x square into d dx of this. So there must be a half here. So this is a mistake. Let me correct it. But here in this PDF file, it is not possible to correct here. There should be a half here, and this 2, the 2 in the denominator and these 2 should be cancelled out. So in the next step, so here 400 minus 2x square into 2x, but there should be a half here. This half and these 2 should be cancelled, so there cannot be any 2 here. Here it is okay, minus 4x into root over 400 minus x square. This minus sign and this minus sign becomes plus, but here there cannot be any 2 here. It should be x into 400 minus 2x square. So let us see what happens. Ultimately, we should get the correct result. There cannot be any 2 here. There cannot be any 2 here. So here it should be, you take the sum of the upper part, your LCM will be root over 400 minus x square, and in the lower part there was root over and then a whole square. So this root over and the power 2 they cancel. So here in the denominator it should be 400 minus x square, and in the upper part the denominator is root over 400 minus x square, and when you do this sum it will be minus 4x into root over this into root over the same thing. So it will be 400 minus x square, and there cannot be any 2. It should be x into 400 minus 2x square. So ultimately what you are getting, this root over and this power 1 plus half should be 3 by 2. Yes, the power should be 3 by 2 here. So here minus 4x into 400 minus x square, and here x into 400 minus 2x square. So you multiply this minus 4x with this. So it will be minus 1600x plus 4x cube. Up to this it is okay. And here it should be 400x minus 2x cube. That's all. There cannot be any 2 here. There cannot be any 2 here. When you do this sum by yourself, please do this correction. So here it should be 400x minus 2x cube. Minus 2x cube. So ultimately what will be there? Minus 1600x plus 400. So it should be minus 1200 into x. Then it is plus 4x cube minus 2x cube. That means it should be plus 2x cube. Now you have to put down the value of 10 into root 2. I think the result will be negative. Whatever the term here, it should be, there should be a 2x cube here. There should be a 2x cube here. Ultimately, you will get a negative number here. Please do this correction. Ultimately, you will get a negative number here. So there was a double prime. There was a double prime. So in all these terms, there should be double prime. There should be double prime. Okay. I will do the corrections and I will upload the file again. It is already uploaded, but I will do the correction and I will upload the file again. I will delete the previous file. So ultimately you will get a negative number here. So there will be a maximum when x equal to 10 into root 2, because the second order derivative becomes less than 0. So you are getting the point x equal to 10 into root 2 for which the area of the rectangle is maximum. So what will be the value of y? The value of y, what was it? It was root over 400 minus x square. So it will be 400 minus 10 into root 2 whole square, and it is simply 200. So 400 minus 200, root over 200, and this is 10 into root 2. So what we see, the values of x and y are same, 10 into root 2 and 10 into root 2. That means the rectangle should be a square. To get a maximum area, these two sides should be equal. That means it should be a square. If it is a square, then you will get a maximum area when it is inscribed in a circle. Okay, so let us now go to the next math. So what is our next question? A cubic container. That means it is a solid figure. It is not in 2 dimension, it is in 3 dimension. A cubic container with a base length twice the width is to be made with 48 meters square of metal, including the lid, Find the dimensions of the container for its maximum value. So you see there is a figure here. This is a cubic container. It is actually a rectangular parallelepiped. Cubic container, that means it is a solid figure, and in total there will be how many faces? There will be 1, 2, 3, 4, 5,
6 faces.
in total. How many faces?
6.
6 faces, right. There will be 6 faces, and in this figure, this is the base. This is the base. B, C, E, H. This is the base. And it is given that in the base, the length is twice the width. So here, this should be the length, and this should be the width. Your length is twice the width. So let us take the width be x. So the length should be twice x.
Miss,
Okay.
what did you say the shape was? I mean, this container is called
Okay, it
rectangular.
is named as rectangular parallelepiped. Rectangular parallelepiped. It is a solid figure. If all the edges are same, then it becomes a cube. Then it becomes a cube. If all the sides are same.
It's
Not
parallel.
sides, all the edges are of same length, it will be a cube. So your cubic container, it means it is a rectangular parallelepiped. These edges should be vertical. These edges should be vertical when this base is horizontal. Okay?
Okay, miss.
Okay? Okay. So this is the width of the base. So twice x should be the length of the base. And your question is, find the dimensions of the container for its maximum volume. Now, how can you get the maximum volume? One thing should be given here. Yes, it is given here. Container is to be made with 48 meters square of the metal. That means this container is made of metal, and 48 meters square. This should be the surface area. The whole surface should be made of this area, 48 meters square. Square means it gives you the area. That means it is the total surface area, because it is also including the lid, the base, the two sides, and actually there are 4 sides here. The base, the 4 sides, and the lid. Lid means it is the upper part, the upper face. Upper face gives you the lid. The whole surface should be made of this 48 meters square of metal. That means this 48 meters square, it is giving you the total surface area. How many surfaces are there? There are 6 surfaces. There are 6 surfaces. Okay. So this for the base, this is the length, this is the length, this is the width, and suppose that the height be h. It is shown here. Suppose that the height be h. Okay, so let us now find the total surface area. Total surface area. That means you have to take into consideration all the 6 surfaces, all the 6 faces. So here 2hx. 2hx means this face A, B, C, D, and E, F, G, H. E, F, G, H, and A, B, C, D. These 2 faces are exactly same. And what will be the area? For this face, it will be h into x, and for this face, it will be hx. So in total, there will be 2hx. There will be 2hx. Okay. Now, let us take these faces. C, E, F, D. C, E, F, D, and B, H, G, A. These 2 faces are exactly same. And here, one side is 2x and the other side is h. So it will be what? There are 2 faces. So 2 into h into 2x. This is the second term. And what remains? What remains? The base and the lid. The area of the base is x into 2x, and the area of the lead also x into 2x. So there should be 2 into x into 2x. So this thing gives this term gives you the area of the base and the lead. And this 2 into h into 2x gives you which sides? These lateral sides, these two lateral sides. And h into x gives these two lateral sides. So this is the total surface area. And here it is given that the total surface should be covered by this metal, 48 meters square. So this whole surface area, should be equal to 48. Please tell me, is it clear to you now?
Yes, miss.
Okay. So let us now simplify this expression. Here 2hx plus 4hx, that means 6hx. And here it is 4x squared. So you are getting 6hx plus 4x squared equal to 48. Let us now find the value of h from this expression. You see here 2 is common in both the sides, so we divide by 2. So it will be 3hx plus 2x squared equal to 24. So the value of h should be what? 24 minus 2x squared divided by 3x. This is the value of h. Okay. Now, what was our question? Find the dimensions of the container. Dimensions means you have to find all the edges. The value of x, which will give you the length, here 2x, the length, x is the width of the base, and h will be the height. These three will give you the dimension. So you have to find the dimension for maximum volume. So now what will be the volume, expression for volume of this container? Volume means what? Length into width into height. So 2x into x into h. That means 2x squared h. Yes. The volume of the container is x into 2x into h. That means 2x squared h. So here, let us put down the value. There are two variables. So to get the first order derivative, let us express it in terms of one variable. So just put down the value of h here. So 2x squared into h is 24 minus 2x squared divided by 3x. 1x cancel out, so it will be 2x into 24 minus 2x squared. So multiply by this 2x. So it will be 48x minus 4x cubed, right? 1x cancel out, so divided by 3. Now you separate the two terms. So 48 by 3 is 16, 16x minus 4 by 3x cubed. So this is the expression for this volume. You can write it, this v, as a function of x. So v of x will be equal to 16x minus 4 by 3x cubed. This is a polynomial function, exists and defined everywhere, continuous everywhere. So what will be the derivative? V prime that means d dx of v, it will be, just differentiate these two terms separately, it will be 16, and here it will be 4 by 3 into 3x squared. So these 3 and these 3 cancel out, so it will be minus 4x squared. You can take 4 common, so it will be 4 into 4 minus x squared. Now, we know that for a maximum or minimum volume, maximum or minimum volume can occur only at the critical points. Maximum or minimum volume occurs only at the critical points, and at the critical points either v prime should be 0 or v prime should not exist. Here, this is a polynomial function, v prime x, it is x16 minus 4x squared. Definitely it is defined and continuous everywhere, so there is no point where this v prime x is undefined. So v prime x exists everywhere. So for the critical point, you have to consider only this condition, v prime x equal to 0. So when it is equal to 0, x squared should be equal to 4. X squared should be equal to 4, that means x should be equal to 2. Here you cannot take x equal to negative 2 because x cannot be negative. So we have only one value of x, which is 2. Which is only one value of x, which is 2. So now this function is very simple function. So you can try with the second derivative test. So you find that second derivative from this expression for first order derivative. This is a constant, so it will give you 0. So here it will be minus 8x. Second order derivative will be minus 8x. Now what is the value of this second order derivative when x equal to 2? So it is minus 8 into 2, it is simple minus 16, which is a negative number. So at the point x equal to 2, the original function Vx will have a maximum. So the volume will be a maximum when x equal to 2. So this is giving you the one of the three dimensions. It is giving you the width. So what will be the value of h? The expression for h was this: 24 minus 2x squared divided by 36. So just put x equal to 2. So 2 squared is 4. 4 into 2 is 8. And ultimately the value is 8 by 3. So the value of h is 8 by 3, x is 2. So what will be the length? It will be 2 into 2, that means 4. So the dimensions of the cubic container for the maximum volume and with 48 meters square of metal in the whole surface are these: 2 meter, 8 by 3 meter. This is the height and this is the length. 2 meter is the width of the base, 4 meter is the length of the base, and 8 by 3 is the height. And sometimes you may be asked for finding the maximum volume. So what will be the maximum volume? This was the expression for the volume. Let us go back. Here, this was the expression for the volume: Vx equal to 16x minus 4 by 3 x cube. And you are getting maximum volume when x equal to 2. So just put x equal to 2, you will get the maximum volume. Put x equal to 2, you are getting the maximum volume, which is 64 by 3. Now it will be m cube, because for volume, the power to this dimension should be 3. The next question. A closed rectangular container. A closed rectangular container with a square base. So you see, the base should be a square. The base should be a square. A closed rectangular container with a square base is to have a volume. So here the volume is fixed. In the previous question, the surface area was fixed. In the previous question, the surface area was fixed, which was 48 meters square. And here the volume is fixed. To have a volume 2000 centimeter cube, it costs twice as much per square centimeter for the top and the bottom as it does for the sides. Find the dimensions of the container of least cost. So what will be the least cost? That means what? When the cost will be minimum. When the cost will be minimum. The cost will be minimum. You see, you are keeping the volume fixed. So the cost depends on what? The cost depends on the surface area. So the surface area should be the minimum. The cost for the surface area should be the minimum. Find the dimensions of the container of least cost. Least cost means cost will be minimum. What will be the dimension when the cost is minimum? So the volume is fixed and is given that the base is a square. So this is our figure. The base is a square. This is the base. B, C, G, H. This is the base, and all the edges should be equal because the base is a square. X, X, this will be X, this will be X. The height should be different. So let us take the height as H. And what will be the volume of the container? You know the volume is what? Length into width into height. So x into h. That means volume should be x square into h. And the volume is kept fixed, which is 2000 centimeter cube, which is given to us. So from this relation, let us find the value of h. It will be 2000 divided by h square. So h will be 2000 divided by x square. Now Let us see what is happening. Suppose the cost per square centimeter, the cost per square centimeter for the surface, definitely the cost per square centimeter for the sides BC. You see, it is given that it costs twice as much per square centimeter for the top and the bottom as it does for the sides. So how many sides are there? There are 4 sides. One, A, E, H, B, one side. A, D, C, B, another side. D, C, G, H, G, F, sorry. D, C, G, F, another side. And E, H, G, F. This is the 4th side. So there are 4 sides and the cost will be twice. When? If you, the cost for the top and the bottom. Yes. For the top and the bottom, the cost will be twice the cost than the cost it takes for the 4 sides. Okay. So let us suppose that the cost for the per square centimeter for the sides is C. For the sides be C, so the cost per square centimeter for the top and the bottom will be 2C. Okay. So the cost for each side, I think it should be written it like this. Suppose the cost per square centimeter for each side, I think it should be mentioned here like this. Suppose that the cost per square centimeter for each side be C. So for the cost per square centimeter for the top and the bottom will be 2C each. It is mentioned here each, but here each was not mentioned. I think each should be mentioned here. Suppose that the cost per square centimeter for each side should be C. So let us see what should be the cost per square centimeter. Per square centimeter is C. So what will be the total cost for each side? So for this side, x square. For the top and the bottom, 2C each. Yes. So for the bottom, at first you take the bottom. Here for the top and the bottom, cost per square centimeter is 2C each. So what is the area at the bottom? The area is x squared. So it should be multiplied. X squared is the area and C was the 2C was the cost per square centimeter for the top and the bottom. So this x squared should be multiplied by 2. And similar is the case for the top. Here also, what are the edges? The top and the bottom will be same. This side should be x, this should be x, this should be x, this should be x, because it is a rectangular container. The face, that bottom and the top are same. Okay, so the top should be also a square. So area of the top should be x squared, and this x squared should be multiplied by 2c. It should be multiplied by 2c. So here x square is multiplied by 2c. This is for the bottom, and x square for the top should be multiplied by 2c. And this term is coming from the 4 sides. So what is the area for the 4 sides? This is x and this height is h. So x into h is the area of any one of the 4 sides. So how many sides are there? There are 4 sides. So it should be 4x into h. And what is the cost per square centimeter for the sides? It is c. So this 4hx should be multiplied by c. And this gives you the total cost. You have to understand this expression clearly. If you have any question, please ask me. If you have any question, please ask me. This cost is for the bottom, this cost is for the top, and this cost is for the 4 sides. For the 4 sides, each takes C, the cost.
It's 2x square into c. It's 2x square into c.
Per square centimeter for each side.
Okay.
For each of the 4 sides. Yes. I think it should be like this. Suppose that the cost per square centimeter for each of the four sides, be C. Okay, so this cost C per square centimeter should be for these four sides. This one, this one, this one, and this one. For the four sides, each will take cost C. So for the four sides, the area are h into x. Each side's area is h into x. So in total, there will be four sides, so 4hx, and it should be multiplied by C. Okay, and for the bottom and the top, the cost per square centimeter is 2c. So the area of the bottom is x squared. X into x is x squared into 2c, plus for the top x squared into 2c. Okay, I think it is clear to you now. The total cost is denoted by C total. Okay, by C total. Now these two terms are exactly same, so it will give you 4cx square, and it is 4chx. So you can take 4c common. If you take 4c common, it will be 8x square plus 8x. Now let us put down the value of h, because the total cost should be expressed in terms of a single variable. Let us put down the value of h. H is 2000 by x square. Put it down here. So 1x cancel out. It should be 4c into x square plus 2000 divided by x. So this is the expression for the total cost. And your question was, the total cost should be minimum of least cost. That means the total cost should be the minimum. So your cost is now a function of x. This is your total cost, and it is now expressed as a function of x. So you must find the derivative. What will be the derivative? This 4c is a constant. So differentiate term by term. It will be 2x, and here it will be minus 1 over x gives you what? Minus 1 by x squared after taking the derivative. So it should be minus 2000 divided by x squared. So you can take 2 common, so it will be 8c into x minus 1000 divided by x squared. So this is the expression for the first order derivative of the total cost. And this total cost will be a maximum or minimum at a critical point. At a critical point, this total cost can have a maximum or minimum. And for a maximum or minimum, the first order derivative must be equal to 0, or it should be undefined. Does not exist. Either c prime x equal to 0 or c prime x does not exist. Here, c prime x does not exist when x equal to 0. Because when x equal to 0, this term becomes infinity and the whole thing becomes infinite. So that's why this total cost will be undefined. It does not exist when x equal to 0. Now, please tell me, can x equal to 0? Can x be equal to 0? No, it is not possible, because it is the edge, length of the edge. It cannot be 0, because if x is 0, it becomes a straight line if only h is there. So x cannot be 0. So we have to consider only one condition for which c prime x equal to 0. So when c prime x equal to 0, this whole thing should be 0. And hc cannot be 0, so x minus 1000 by x square should be equal to 0. So you do this algebra, x into x square will be x cube minus 1000 divided by x square. So you are getting x cube equal to 1000. So what will be the value of x? X should be 10. So for x equal to 10, the the cost can be maximum or minimum. For x equal to 10, there could be a maximum or minimum for c. So now you have to test. Yes? Yes?
No, miss. No,
Okay.
it's nothing.
Okay. So let us now find the second order derivative, because we want to we want to check with the second order derivative. So what will be the derivative of this thing? You see, for x you will get 1. For x you will get 1, and for this the power of x is minus 2. So this minus into minus 2 into x to the power minus 3. So it will be 8c into 1. This sign should be plus. 2 into 1000 is 2000, and x to the power minus 3 means 1 over x cube. So this is the expression for the second order derivative of this cost. So now let us put down the value of x, which we have got, it is 10. So what is the second order derivative becomes? If you put 10 here, ultimately it gives you positive number 24c, which is a positive number. So the cost will be minimum. Okay, the cost will be minimum because the second order derivative becomes a positive number for this x equal to 10. So when x equal to 10, the cost will be minimum. So it is very clear. So the cost will be the least. Least means minimum when the age of the base is x equal to 10. So h should be equal to 2000 by h squared. That means 2000 by 100. That means 20. So what will be the dimensions? The dimensions will be 10, 10 and 20. 10, 10 and 20 because h becomes 20. H becomes 20. So these are the dimensions. So next question. Okay, now comes the cylinder. Find the dimension and the minimum surface area of a cylindrical can that is required to hold 750 centimeter cube volume of the liquid. So this is a right circular cylinder. Right circular cylindrical. So for simplicity, we are considering right circular cylinder. And for a right circular cylinder, the top and the bottom is a circle. For a right circular cylinder, the bottom and the top is a circle. Both of them are circles, and this height is vertical. This line is vertical. Okay, so let us consider this right circular cylinder whose base is a circle, and let us suppose that the radius of the base is r and the height of the cylinder be h. The height of the cylinder be h and the radius of the base is r. Okay, and what is your question? What will be the dimension for minimum surface area? So this curved surface, this is called the lateral surface. This is the curved surface, and there is a base which is a circle. There is a top which is a circle. The total area gives you the total surface area, and it should be a minimum. And the volume which you are keeping here inside the cylinder, it has the volume 750 centimeter cube. So this 750 centimeter cube should be taken as the volume of this cylinder. Okay, so this 50 centimeter cube, which is fixed for this cylinder. Okay, and we have to find the dimensions for the minimum surface area. And please tell me what will be the volume of this right circular cylinder. Do you know this formula?
Inspire
R square H. Yes, it gives you the volume of the cylinder. If R is the radius of the base and H is the height of the cylinder, then the volume of the cylinder will be pi R square H, and it is given, it is fixed. Volume is fixed, it is 750. So you have to find the value of H. H will be 750 divided by pi R square. Okay, now let us find the surface area, the whole surface area. The whole surface area is equal to what? The area of the lateral surface. Lateral means the curved surface plus the area of the base and the top. The base is a circle and its area is pi r square. The top is also a circle of same area, so this will be also pi r square. So pi r square plus pi r square, it will be 2 pi r square. Pi r square plus pi r square, it is 2 pi r square, and there is a formula for finding the area of the curved surface. It is 2 pi r h. 2 pi RH. 2 pi r is actually the perimeter of the base, and you have to multiply it by height. It will give you the area of the curved surface. The whole surface area is equal to area of the curved surface plus the area of the bottom and the top. So ultimately, if S be the total surface area, it will be 2 pi r square plus 2 pi r h. Here it is a function of two variables r and h. Let us make it 1 by putting the value of h here. H is 750 by pi r square. So now S can be expressed as a function of R. Here it is 2 pi r square plus 2 pi r into this. Pi cancel out, 1 r cancel out. 750 into 2 is 1500 divided by r. So we have to find the derivative. So S prime r, we have to differentiate it with respect to r. So it will be, pi is a constant. So it will be 2 into 2, 4 pi r. And here 1 over r, 1500 is constant. 1 over r gives you what? 1 over r means r to the power minus 1. So it will be minus r to the power minus 2. That means minus 1 over r square. So this is the expression for the first derivative of the surface area. Now, for a maximum or minimum, the maximum or minimum of this surface area may occur at a critical point. And for the critical point, this derivative, either the derivative will be 0 or the derivative should be equal to infinity, undefined. Either S prime r equal to 0 or S prime r does not exist. Now let us check the second condition. This S prime r does not exist when r equals to 0, because when you put r equals to 0, this term becomes undefined, infinity. So the whole thing becomes infinity. That means S prime r does not exist. And is it possible for r to be equal to 0? No, because r is the radius of the base. It cannot be 0, because if r is 0, the base becomes a point and the cylinder becomes a vertical line. So r cannot be 0. So there is no point for which this surface area of the cylinder should be undefined. So there remains only one condition, S prime r equal to 0. So let us check this condition. This thing should be equal to 0. So r cube, 4r cube should be equal to 1500. Yes, 4 pi r cube equal to 1500. So r cube should be equal to 1500 by 4 pi. So r will be what? You have to take the power 1/3 on both sides. Take the power 1/3 on both sides. So in the left side it will be r, and in the right side it will be 1500 divided by 4 pi whole to the power 1/3. And use your calculator, it will be 4.9 centimeter. So this is a critical point of the function SR. Now we will check whether at this point there is a maximum or minimum. So for this you have to find the second order derivative. So you have to differentiate it again. So S double prime should be equal to 4 pi. DDR, we have to differentiate with respect to R. So ddr of r is 1, so it will be 4 pi, and here 1500 is constant, that means r to the power minus 2. So minus 2 into r to the power minus 3. So minus 2 and minus, it will be plus, so it will be plus 1500 by r cube. Yes. This is the expression for second order derivative. 4 pi plus 3000 divided by r cube. What was our r? R was 4.9. So you just put here r equal to 4.9, use your calculator, and this is a positive number. It shows here, we don't need to find the value of this, because this is a positive number, this is a positive number, the sum of these two must be a positive number. So for the value r equal to 4.9, the surface area S will be a minimum, which shows that the surface area will be minimum when r equal to 4.9. So the other thing for the dimension, which is the height was equal to 750 by pi r square. So you just put down the value of r, 750 by pi into 4.9 whole square, it is 9.44943. So these are the dimensions. The dimensions of the cylindrical can will be 4.9, which is the radius of the base, and the height of the cylinder should be 9.943 centimeter. And what will be the minimum surface area? What was the expression for S? This was the expression for S. S is equal to 2 pi r square plus 1500 by r. So just put down r equal to 4.9. You will get the minimum surface area. So this is the minimum surface area. Just put down r equal to 4.9. Okay. There is another math involving the right circular cylinder. So what is our question? What is the maximum volume in liters of a paint that can use 1345.9 centimeters square of steel? Can you please tell me which value is given to us? Please tell me. What does this number give?
Surface area.
Surface area.
Surface area.
Yes, very good. This gives you the total surface area of this cylinder. So for simplicity, it is not mentioned here that what is the shape of the container. So for simplicity, let us suppose that it is a cylinder. Let the paint be kept in a right circular cylinder. When you consider a right circular cylinder, the base and the top are circles of same size, and the height, this height is the vertical line. Okay. So let the paint be kept in a right circular cylinder made of steel, because the material should be steel, with surface area. Total surface area should be 1345.9 centimeters square. So you have to look for maximum volume. Okay, so this thing is given to us. So at first you write down the total surface area. Total surface area, we have just found it in the previous math. It is equal to the what? Area of the top and the bottom. These two are circles. So pi r square plus pi r square, that means 2 pi r square, and the area of the curved surface, that means the lateral surface, is 2 pi r8. And this whole thing should be equal to this 1345.9. 2 pi r square plus 2 pi r8 should be equal to this. So let us now find the value of h from this relation. So 2 pi r8 should be equal to this minus 2 pi r square. So h should be equal to this whole thing divided by 2 pi r. Okay. Now, what is the volume? The volume of the cylinder is pi r square h. This is the formula for the volume. Here we have two variables. So let us express the volume in terms of a single variable. So just put down the value of r here. So pi r square into the value of h is this. 1 r cancel out, pi cancel out. So here remains 1 r. So it should be what? R into this whole thing divided by 2. So this thing divided by 2 is this. 672.95 into r minus these two to cancel out. So pi r square into r, that means pi r cube. So this is the expression for the volume. Please turn off your microphones. VR equal to 672.95 r minus pi r cube. So, you know, for maximum or minimum, you must find the critical point, and for critical point, either the derivative is 0 or the derivative is undefined. So we have to find the first order derivative of this volume. So differentiate it. DDR of R is 1, so just this number 672.95, and for this term you are getting 3 pi r square. So this is the expression for V prime R. Now for maximum or minimum volume of the cylinder, V prime R equal to 0 or V prime R does not exist. Here this is a polynomial function. So for any value of R, V prime R exists. So there is no point where this expression does not exist. So we have only one condition remaining. This should be equal to 0. So if it is 0, what is the value of r square? So r square will be this thing divided by 3 pi. That means r should be equal to this thing whole to the power half. And using your calculator, you are getting the value of r, which is 8.45. So this is the value for the r, for which you may get a maximum, either a maximum or a minimum. So to decide whether there is a maximum or minimum, you have to find the second order derivative. This is a constant. So this will give you 0, and for this one it will be minus 6 pi r. V double prime should be minus 6 pi r, and if you now put down the value of r equals to 8.45, and these things definitely it is a negative number. So since the second order derivative becomes negative for this r, the volume will be maximum. The volume of the cylinder will be maximum when r equal to this. So that is the volume of the paint will be maximum. Volume of the cylinder will be maximum. That means volume of the paint will be maximum when R equal to 8.45. And the maximum volume of the paint will be this. Okay. So what was our question actually? What is the maximum volume? Okay. The dimensions are not asked here. What is the maximum volume? So in the expression for the volume, you just put down the value of R. This was the expression for the volume. So for maximum R should be equal to this. So this is the maximum volume. Okay. Now the next one. It's another math on what? Cylinder. There are two more maths remaining. I think you can go through it by yourself because the formulas are same. Volume equal to pi r square h and surface area this. You please go through this math by yourself. I'm going to the next math. It is similar to the previous one because the next maths are little different. This is a different math, different type. Look into this question. A rectangular sheet of paper with parameter 39 centimeter is rolled into a cylinder. What dimensions of the sheet would maximize the volume of the cylinder? So actually, at first we have a rectangular sheet of paper. Rectangular sheet of paper. So let us suppose that one side is X and the other side is H. This rectangular sheet should be rolled. If you rolled it, keeping this H as a vertical, keeping this H vertical, if you rolled it by rolling this side, by rolling this edge, you will get a cylinder, right circular cylinder. If you keep this edge height fixed as a vertical, okay, you will get a rectangular, sorry, you will get a right circular cylinder where the base and the top will be a circle. Okay, and the question is what? Rectangular sheet of paper with perimeter 39 centimeter. That means the perimeter of this rectangular sheet is fixed, which is 39. That means this side is X, this side is X. So total perimeter will be 2X plus 2H should be equal to 39. Yes. 2x plus 2h should be equal to 39. So the value of h should be 39 minus 2x divided by 2. This should be the value of h. Now this rectangular sheet is converted, after rolling it, it is converted to a right circular cylinder. So this height remains the same. H will be same, and what will be the perimeter of this circle? Can you please tell me? One of you, please tell me what will be the perimeter of this circle? This sheet is rolled.
Perimeter of the page.
Yes. So what will be the
2 pi x.
No, if you take r as the radius of the base, if you take r as the radius of
2 pi
the
r.
it is a 2 pi r will be equal to the area of the base. And what will be, I'm not asking about the, sorry, 2 pi r will be the perimeter. 2 pi r will be the perimeter of this base. This is okay. 2 pi r will be the perimeter of this base, and what will should be the value of this 2 pi r, because this circle is formed by rolling this rectangular sheet around, rolling it around this height.
Ma'am, can you please repeat the question?
Sorry?
Can you please repeat the question, ma'am?
Okay, can you, so I am repeating the question. You see this sheet, this rectangular sheet is rolled into a cylinder. By rolling this whole sheet around this height is kept fixed. This whole thing is rolled around this height, this line, around this height. Okay, and you are getting this right circular cylinder where the base is a circle and whose radius, the radius of the base is taken as r. And you know the perimeter of this circle is 2 pi r. Can you say what will be the value of this 2 pi r? What should be the perimeter of this circle? Think about it.
Ma'am,
Is
it
2
should be
pi r
X.
equals to x?
X, very good. It should be equal to X because when you roll it around this edge, this length X becomes the perimeter of the circle. This length X. What is your name? Who have answered this question? Please tell me your name. The girl.
It's Aisha
Uh,
bint Hassan.
Sorry?
Tasim Ahmed.
Aisha bint Hassan.
Aisha, very good. This X becomes, this whole X, this length becomes the perimeter of this circle. So 2 pi r must be equal to X. This is the relation. This 2 pi r must be equal to X. We will use this relation later on. Now, we have to find for the maximum volume. The volume should be maximized. Okay. So what is the volume of the cylinder? You know it. The volume of the cylinder is V equal to pi r square h. So let us express it in terms of a single variable. You know the value of h. H is 39 minus 2x by 2. So just put it here. So it will be pi r square into 39 minus 2x by 2. Now you can put down the value of x. What is the x? Because you are getting two variables here, two unknowns. One is r and the other is x. So you know the value of x. X is 2 pi r. You just put it here. You just put it here. So it should be 4 pi r. Now this whole volume v of r becomes a function of r only. Now it is easy for us to find the derivative. So we have separated the two terms. So the first term will be 39 pi by 2, 39 pi by 2 r square, and the second term 1 4 will cancel out. It will be 2 pi square r cube. Yes, 2 pi square r cube. Now you find the derivative. 39 by 2 pi is constant. So 39 by 2 into pi into 2r. So 2 to cancel out, it will be simply 39 pi r, and here 2 pi square is constant, and from r cube you are getting 3 r square. So 3 into 2 is 6, 6 pi square r square. So the expression for the first derivative of the volume, it is, you can take 3 pi r common, so it will be 13 minus 3 pi r is taken common, so it will be 2 pi r. 3 pi r into 13 minus 2 pi r. So for the maximum or minimum volume of the cylinder, you must have v prime should be equal to 0 or v prime undefined. Here v prime is defined everywhere because this is a polynomial function in R. There is no value of R for which this v prime becomes undefined. So there remains only one condition, which is v prime r should be equal to 0. That means this should be equal to 0. So when this whole thing becomes 0, what are the values of r? There are two values of r. One is 0, r can be equal to 0, or 13 minus 2 pi r equals to 0. That means r equal to 13 by 2 pi. Now, look into the figure. Can this r be 0? Can this r be 0? No. This
No.
r cannot be 0. Because if this r is 0, this circle becomes a point, which is not possible. So the possible value of r is 13 by 2 pi. So you have to check whether at this value r equal to 13 by 2 pi, whether there is a maximum or minimum for the function, volume function. So you have to find the second order derivative of this v prime. So if you take again the derivative, this is 39 pi into r. So it will be simply 39 pi minus r square. R square gives you 2r. So it will be 12 pi square r. Yes, 12 pi square. Was there a minus sign? Yes, there was a minus sign. So V double prime R should be 39 pi minus 12 pi square R. Okay. Now let us put down the value of R. R is 13 by 2 pi. Do the calculation and finally it is minus 39 by pi, which is a negative number. So the volume will be maximum when R equal to 13 by 2 pi. The volume will be maximum when R equal to 3 by 2 pi, and you can easily find the dimension of the rectangular sheet. X equal to 2 pi R, just put down the value of R. It will be 13, and here for the expression for H, it was 39 minus 2x by 2. X is 13, so it is 13 by 2. So the value of X is what? X is it is 13 and it is 13 by 2. So this should be the dimension of the rectangular sheet for which you will get a maximum volume of the cylinder. Okay, I think we can do another math here. Because we have 8 minutes left. Let us try this one. A church window. A church window consisting of a rectangle. So this is the whole window. This is the whole window and it consists a rectangle. So the lower part is a rectangle. This is the rectangle by a semicircle, topped by a semicircle. That means the semicircle is in the upper part. Topped by a semicircle means in the top of this rectangle there is a semicircle. Is to have a perimeter P. So the perimeter of this window is fixed. The perimeter means this whole length. If you start here, it will be this, then this side, then again this side, and stop here. This should be the whole perimeter and it is fixed. It is P, capital P. Find the radius of the semicircle. This is the semicircle. So the radius should be here. Find the radius of the semicircle if the area of the window is to be maximum. Also find the maximum area. If the area of the window is to be maximum, also find the maximum area. So the perimeter is fixed. So let us at first find the perimeter of this window. So at first you have to find this length. If this radius of the semicircle is R, this whole length should be 2R. So this length should be also 2R. So 2R is the length of this side. And if you take the length of this side as H, this side will be also H. So the perimeter coming from the rectangle will be 2H plus 2R. This side is in the inside. So if this side cannot be the perimeter, this side, the upper part of this rectangle cannot be included in the perimeter. In the perimeter, there should be 3 sides of the rectangle and this semicircle. What is the area of a full circle? If the radius is R,
Pi R square.
no, not area. We are finding the perimeter.
Circumference.
Yes, perimeter is 2 pi R. So for the semicircle, the perimeter should be pi R. So what you are getting? You are getting pi R. It is the perimeter of the semicircle. Perimeter of the semicircle is pi R. And this side is 2R. And this side plus this side is 2H. This whole thing is P. So let us find the value of H here. H will be P minus pi R minus 2R divided by 2. And you can take R common, it will be minus pi plus 2. So this is the expression for H. Now you have to find the area which should be maximum. The area should be maximum. Area of the window should be maximum. So let us now find the area of the window. When you find the area of the window, at first you find the area of this rectangle and the area of the semicircle. Area of the window, sorry, rectangle should be 2R into H. Yes, 2R into H, and the area of the full circle is pi R square. So the area of this same circle will be half pi R square. So this is the area of the window. A should be half pi r square plus 2 pi r h. So just put down the value of h here, so it becomes a function of r. We do not have much time, so I go in short. AR is this, and for critical points for maximum or minimum, you have to find the derivative. So after getting the derivative, this is the expression. After getting the derivative, this is the expression, and for maximum or minimum, it should be 0 or undefined. But there is no value of r. This is a polynomial in R, first degree polynomial in R. So there is no value of R for which this becomes undefined. So there is only one condition, A prime should be 0. And if you consider it is 0, what will be the value of this R? R should be P divided by pi plus 4. So this should be the value of this R. The radius should be P by pi plus 4. This was your question. Find the radius of the semicircle if the area of the window is to be maximum. So the area for the maximum area of, so the radius of the semicircle for maximum area of the window should be this. R equal to P by pi plus 4. And what will be the maximum area? Okay, I have checked it here. We have found, I forgot about this one. We have to find the second order derivative of this. The second order derivative of this should be what? It should be just minus of pi plus 4 because P is a constant and derivative of R is 1. So it will be just minus of pi plus 4. Minus of pi plus 4, it is always a negative value, negative number for all value of R. So for the value of this R, P by pi plus 4, the area will be always a maximum because the second order derivative is always a negative. So the maximum area of the window will be this. Just put down the value of R in the expression for R, in the expression for area. A maximum should be equal to this when R equal to this. And finally, you are getting what? After calculation, this gives you the area of the maximum area of the window. P square by 2 into pi plus 4. There is another math, but I do not have much time for this. You can go through it by yourself. We have done a lot of math on this application of, if you want, I can do it in our next class because in this math, we have followed a different way. This math is solved in a different way. So let us do it in our next class because we
Miss,
do not have much
attendance na
time.
hoyni.
Oh, I totally forgot. I'm sorry. I'm sorry. Do we have time? I think we have time here. Oh. Just a minute. Just a minute. Stop sharing. Stop sharing. Stop recording. And then what? Where I'm getting this? Okay, I think I get this. Yes. I have got it.